Alright, good morning all. You're welcome to our lectures today on pharmaceutical calculations, BDT 253. Today we'll start with a new topic, variation. Still under the topic grouped together as ratio, proportion, and what? Variation. Ratio, proportion, and variation. So today we go into what? Variation. Okay. Just as you have ratio, proportion, in ratio and proportion you have that two or more quantities are involved. Am I communicating? So it talks about the relationship. Variation also, you're aware that ratio talks about a relationship between two quantities, right? The same way proportion also talks about, but proportion are now for items, right? The same way variation talks about the relationship between two or more items and how what happens to one item affects the other item. So in variation, variation simply talks about how change. First of all, it talks about the relationship between two or more items. But specifically, it talks about ratio, proportion talks about the relative magnitude. But variation talks about how changes in one item affect, how any change in one item can affect the change in the other item. That's what variation is all about. That's where it's coming from. That's where the angle variation explains the relationship between two or more items. Ratio compare their magnitude. Am I communicating? Ratio compare their magnitude. And in a proportion, we have two ratios in proportion. But variation talks about the change in one of the items. How does it affect the other item or items, as the case may be? That's what variation talks about. That's why in variation we have different types of variation. We have direct variation. We have inverse. Sometimes we call it indirect, okay? We have joint variation, and we have partial variation. Direct variation, indirect or inverse variation, joint variation, and partial variation. So we will take them one after the other. I wouldn't want us to waste time there, so we can finish this topic and start our quiz immediately. No time to waste. Now look at this direct variation. Remember I said variation deals with relationship between item with respect to how changes in one affect the other. Now in indirect variation, two items, what it means that as an increase is a change, right? A decrease is a change. So in indirect variation, as the magnitude of one increases, the magnitude of the other does also increase. That is direct variation. It's not reduced, it's increased. That is direct variation. The same way, as the magnitude of the other decreases, the other one does decreases too. That's what direct.
Yes.
as magnitude of one increases, the magnitude of the other does what? Increase too. As the magnitude of the other one decreases, magnitude of the other does what? Decreases too. So whatever happens to the other one also happens to the other one. They may not be at the same amount, but the main thing is that it will also do what? Increase in the same direction. The focus is the change will be the change is in the same what? Direction. So as one is increasing, the other one is increasing too. And as one is decreasing, the other one is what? Decreasing. That is a direct variation. And mathematically, let's assume that this items we are talking about, let's assume that the item we are talking about, the item can be quantities, physical quantities or anything. Let's assume that the item, let's take the items we are talking about to be X and Y. Let's take the items we are talking about to be what? X and Y. So this is first item, X. First item, X. Second item, what? Y. So direct variation can be represented like this, X, Y. X, sign of, this thing is a sign of what? This alpha is a sign of what? Proportionality, okay? Is sign of what? Proportionality. So this means this is interpreted as X is directly proportional to what? Y. So what it means is that as S increases, Y does what? Increase. As X decreases, Y does what? Decreases. Now, but there's something here. Before you can use this to solve any calculation, you need to remove this sign of proportionality and replace it with what? Equal to. And if you do that, that will lead to introduction of a what? A constant. Because as you know, do you know why you need this constant? You know, if X is increasing, Y is also increasing. Your attention, your interest is only in X and Y. There may be other factors that can still cause a change in any of them. So you kept all those factors what? Constant. Before you can focus on what? X and Y. Provided that the other factors are what? Constant. Because if the other factors you don't keep at constant, it will affect the other change. You won't even know, like that. If you come here now, like that. Let me make this more practical. If your focus is on, if you are comparing the students in this class now, let me just say I'm comparing Blessing and Precious. I want to compare their coming to school on lecture on time and their academic what? Performance. We know, we can say, okay, coming to lecture on time is directly proportional to your academic what? Performance. It should, right? Yes. Good. Now, but are you aware there are also other factors that may affect academic performance apart from coming to lecture on time? Blessing may be coming to lecture on time. Precious may not be coming to lecture on time. Blessing, after lecture, Blessing may go home, he won't read her study. She won't do her studying, doing assignment. These are factors. She may not do her assignments. She may not even read. Precious may not be coming on time, but she will after the lecture she will get a note from those that came and go back and do all the assignment given. If us will copy from other people's own and study and have a better result than what? Blessing. Because there are other factors that also may affect what? Academic what? Performance. So if you now say to be able to study the impacts of coming to lecture on time academic performance between two of them, you need to keep studying what? Constant. Doing assignment what? Constant. And other factors constant. And how will you do it? Two of them will make sure that they are doing the assignments as at when due. And two of them will go and read at the same time. Also, intelligence quotient also affects. Let's assume you can okay they have the same. If you want to keep IQ constant, you may get people that have the same IQ level. If paying your school fees on time, if you don't pay your school fees on time, emotionally you'll be disturbed. True of us, you can't rush to read. True of us, paying school fees on time, you keep it constant. They pay their school fees on time. Eating well is constant. They eat the same type of food. They sleep well. You keep all those things constant. As in every other factor is the same thing for both of them. That's what we mean by keeping those things what? Constant. The only thing that varies, the only thing you will vary is blessing coming to class before. Any other constant, any other factors, two of them are doing the same thing in other aspect. That's the meaning of that constant. You will introduce every other thing, all those things are brought together as what? Constant. So to remove this thing now, you now introduce a what? Constant. Then x is now equal to what? The constant may be k. X is now equal to what? Ky. This thing now is an equation of relationship between x and what? Y. Am I communicating? Then before you do the calculation, sometimes they may give you a value of x at a point, give you value of y at the same point. Maybe after some time, the two values will change. They may give you value of x at a point, give you value of y at the same point. X is 2, while when y is 3. Then you may not be asked to find x when y is 4. Am I communicating? Now you use that first set of value for x and y to find k, the constant. So whatever, let's use this I say now to talk about to describe what I mean. You have when x, let's assume that x is what? 2. When y is what? 3. You may not ask to find x when y is what? Y is what? 4. Am I communicating? It is expected that the value of x should also increase because y has done what? Increase. Now, to find this, to solve this type of calculation, there are two things you can do. You can solve it directly. That is the type of formula they use in gas laws. Maybe Boyle's law, P1V, Charles law, sorry. V1 over T1 is equal to V2 over T2. You can solve directly. Ignore the what? Integrate the constant inside it and solve it directly. But sometimes the question may ask you to find a formula or relationship between the two quantities. In that case, you need to find the constant first. So taking that to this nice, I told you now, I will solve this thing through in two ways to explain what I mean. Here, now, you have known y to be 3 and s is what? 2. You find k. From this relationship now, k is what? X over what? Y, which is now equal to s is what here? 2. When y is what? 3. So that means k is what? You now put it back to this equation. That means x is now equal to what? 2 over 3 what? Y. This is the formula connecting what? X and what? Y. Sometimes the question may just want you to get the formula connecting what? X and Y. So you can find a formula like this. If that's the question, you have gotten the answer. They may not ask you again, with this formula now, whatever value of Y, you can easily use from formula to find what X is. True of us. Whatever value of X given, you can use it from formula to find what? The value of what? y. Now let's use the formula to find the value of y, the value of x. Where we are told that y has changed to what now? 4. So how will x change? So x is now equal to what? Simply substitute 4 for y and get the answer. X is now equal to what? 2 over what? Times what? 4. Which is what? 8 over what? 3. Which is what? 2 over what? 2 over what? 3. Are we there? This is the value of. Have you now seen that y increased to 4? X also did what? Increased. True of us? True of us? So this is what direct variation. Now, if you like, you can put it directly, swallow k, and get something like this. Derive the formula and get, of the two changes. You have that. We agree that x, if x we agree that if x we agree that if x is directly proportional to y, that means x is what? K what? Y. Then k is what? S over y. From at this point now, whatever value of x over y will give you the same k. At any point in time, k is what? Constant. So that means k1, first k1 is equal to what? K2. So whatever value k is what? Constant. The constant is not changing because we have kept them what? Those other factors what? Constant. Now from here now, if k1 is equal to k2 and k is s over y, that means x1 over y1 is equal to what? S2 over what? Y2. Because k1 is actually what? X1 over what? Y1. And k2 is what? X over what? Y2. And because k is constant all the time, so that means x1 over y1 is equal to what? X2 over what? Y2. Remember from the question, we were given the first set of x and the first set of first set of values for x and y to be what? Here x1 from this question now, x1 is what? 2, right? So we get 2 over what? Y1 is what? 3. Is now equal to what? X2 is what? No, I say I will use this method to solve it again. I want to show you 2 methods you can use to solve this. So S2 is what then? We don't know. That's what I'm looking for. It's not true. It's X you are looking for. Then Y2 is what? Good, 4. So if you cross multiply, have you seen why we did ratio first? And proportion. We have arrived at that same point again. If you cross multiply, you get that X2 is now what? 2 times what? 4 over what? 3, which is what? 8 over what? 3, which is what? Have you not seen? You can use this method if you know how to use it. Well, maybe if the question doesn't require you to find a formula connecting the what? The 2 items. But if you are asked to find a formula connecting the 2 items, just use this method and stop here. Okay? So with this now, this is what joint direct variation is all about. We can now solve 1 or 2 questions from there. Then we move to what? Inverse or indirect what? Variation. Any questions so far before we solve an example? Any questions so far? So no question. Now let's solve this example. You can look at our course materials. Who is there? Just pick any question there. Let me solve it. Let's solve it. Pick any question from our course material, let's solve it. Okay, sorry. Can I clean here? Okay. So pick any question from our course material, let's solve one. Let's solve at least one or two questions before we go to indirect or inverse variation. Look for a question that demands us to find the formula connecting the items. Then you can look for another one that just wants us to find. There are some you will see, they will ask you for A, find a formula connecting them, find the value of X, X when Y is whatever. So get questions in that form so we can use that to explain everything we've done here now. Number 11 says what? Come and write on the board for us fast. Fast. Okay, let's look at this question. The question says, if D is directly proportional to what? S. And D is 140 when S is 35. Find A, the relationship between D and S. B, the value of S when D is what? 176. Now let's go. If you watch now, if you use this pattern now, you may find you may have issues finding A, solving A. Am I completing? You may have issues what? Solving A. So the best thing is to just use the first method that I spoke about. Now let's solve this. The relationship, the defined relationship is that D is directly proportional to what? S. We can call our constant what? K. That means D is what? K what? KS. So that means K is what? D over what? S. So let's find K. What is the first set of value for D and S? 140 and what? 35. Which is what? 20, right? 20, right? Is it 4? Yes. Okay, 4. Thank you. Which is what? 4. Good. Now, so that means K is what? 4. You now use this value of K to replace it in this what? In this equation, right? So this implies that D is what? 4 what? This is the relationship between what? D and S. What it means that the value of D is 4 times the value of what? That's the meaning. So for whatever value of D given, you can find the value of what? S. And for whatever value of S given, you can find the value of what? D. So having that at the back of our mind, let's now, because of the B part, this is A part, we have solved A part. This is the relationship between D and S. Yes. I say that, but you got how, you understood how we got to this level. Yes. I say that this is the relationship between D and S. Or the formula connecting D and what? X. We call it linking formula, or formula linking D and what? S. It can come in any of these forms. Relationship, formula, linking formula, connecting formula, or linking formula, D and S. What this means is that D will always be 4 times the value of what? S. That's the meaning. And if S is 2, D will what? 4 times 2 is what? 8. Any value of S, D will be what? 4 times the value of S. 4 is a constant, hope you know. And it's a collection of other factors. You kept them at what? Constant. So that you can vary the 2 that are important to what? To you. You want to do what? Study. I think I've explained that here. Those that came late may not understand that. That's what you miss when you come late to lectures. Now, so the second part says what? B.
Find the value of S when D.
So when D is 146, 176, we can find the value of S. From this linking formula, make it S the subject of the formula. That means S is actually what? D over what? 4. This also means that that the value of S is 1/4 of the what? Value of D. Or simply say S has quarter value of the what? D. So any value of D given, S will be the quarter of it. Is it clear? That's the meaning. So if you now know that S is D over 4, we are given that D is what here? 176. So simply substitute 176 for D here. So we now have what? 176 over what? 4. Which is what? 44. Is it 44?
Yes.
So the value of S here is now what? 44. The value of S is now what? 44. (44 times 4 is what? Good. So this is most of the questions you'll be seeing in this that direct variation are rooted in what we just did here. Questions you see here are rooted in what you just see here. They'll just be changing, twisting figures. Am I completing? But if you understood what we explained here, there's no question you will not answer. You cannot answer in what? Direct variation. Some may come in word form, some may be word problem. If you understand this, even if it's a word problem, you can solve it. Even if it's a real life scenario, if you did not use abstract terms, you can still do what? Solve it. So I want us to solve one more before we go to the indirect variation or inverse variation. One more question. Okay, let's look at this question. The question says, let's see, phone naga major of password. You know, is here. All right. If a man circles 15 kilometers in 1 hour, how far will he cycle in 3 hours if he keeps up the same rates? Now, the two factors, the two items here now is in what? Distance and what?
Hours.
And time, right? True of us, distance and what? Time. Now, so we can designate distance to be what? D, and time to be what? T. Are we together? It says, let's go back to the question again. If a man circles 15 kilometers in what? 1 hour. How far will he circle in what? In T what? Hours. Now, from this expression now, do you think the relationship is direct or inverse? Between D and T, do you think it's direct or inverse? Do you think it will take more time to cover more distance? Or will it take less time to cover more distance? Do you think it should be direct? Huh? Do you think it should be what? Direct? It's direct now, right? It's what? Direct. True of us, we are talking about the same man. And that's why they added the same rate. Am I communicating? Good. It's constant, right? The rate is constant, right? Good. And it's the same man. So if every other thing is constant, and we are talking about what? The same man. The same rates. the same man, human beings, is just the same man, not two individuals with two different energies. The same man, and it's still the same rate. All those things will contribute to the constant, true of us. But what varies now is the distance and the what? Time. And if it's the same man, the same rate, that means what should exist between two of them, the two items, is direct variation. Because it will take all things being kept constant. It will take more time to cover more what? Distance. True of us? True of us? Good. But if the man is somehow hungry, was weak when he did the first one, and the man, and after some time he now rested and ate well, he will take less time to cover more distance. True of us? But they are saying everything is for the same rate. So that same rate means constant. You kept every other thing what? Constant. Now what we are varying now is what? The distance and the what? Time. And that the relationship is a direct one. True of us. Now with this we can now say that D is directly proportional to what? T. That D is what? Directly proportional to what? Rates. Time, sorry. Now, we can now introduce our constants to change this to what? Equality sign. So that means that D is now equal to what? KT. Here now, we are not told to find any linking formula. If you like, you can use that method I used. D1, T1, if K is D over T. At this point, you may not need to go and find solving for K because you're not asked to find what? Linking formula. You can simply say if the K is D over T, that means D1 over T1 is equal to what? D2 over what? T2. True of us. You don't need to find K again and start going back again because you have no business with finding their what? Linking what? Formula. If you know this thing well, simply say at this point that D1 over what is equal to what? Remember what I said you should use something like this when you are not asked to find the what? Linking formula. You just want to find the new value of T when this one changes. Simply, once you have gotten the value of K to be D over T, K is constant. Let's assume that when we enter inverse variation, you will see that K will be giving something like this, dt. Sorry, maybe D or any quantity or xy. Let's assume in when we go to inverse, you see that K will give you xy. And if you want to do something like this, just simply say x1, y1 is equal to what? Which gas law talks about this? Boyle's law, right? That volume is inversely proportional to what? Pressure, right? That is Boyle's law. But Charles' law has something like this. Charles' law is a direct variation. That says that the volume is directly proportional to what? The temperature. That's why you have V1 over T1 is equal to what? V2 over what? T2. Now with this we can solve this. You already know the value. What is the value of D1 in this question? 15 what? Please don't throw away your unit too. I don't joke with units. So it's what? D is now what? 15 kilometers over what? T1 is what? 1 hour. Is equal to D2 is what? We don't know. That's what I'm looking for, right? D2 over what? T2 is what? T hours. Good. T hours. They didn't give you any value. They just say T hour. So leave it at what? T what? Hours. So we are looking for what? D2. Let's make D2 the subject of the formula. We cross multiply, right? And we have that D2 is equal to what? 15 kilometers times T what? Hour. Over what? 1 hour. Hour will cancel hour. So the answer is what? 15 kilometers times T is what? 15 T what? Kilometer. That's the answer. That is the what? The how far it will go if you circle for what? T what? hours. Answer only 2 questions. If you keep answering all the questions in that means we remain in one topic for how many hours? And it will help us. Go and study that one. It's easy. I have laid the foundation for any other question you are giving me now. Is based on what I've explained. If you think I'm lying, come and write on the board. Then after writing, you solve it because you go to the board and write it. Go. If you see calculation, there are some questions in calculation that have the same question, but they just be changing the what? Values. I've answered the most important question that you need, that you will see in this thing. Either they want you to do this directly, or they want you to find the linking what? Formula. And if you understood those two, if you have a better understanding of the two of them, you cannot solve any question. You cannot have issue solving any question. If eggs cost 25 naira each, how much will n eggs cost? If eggs, let me finish that question. Kedia? Number 4. Okay. Hello? She asked, if eggs, they just say if eggs. It's just grammar. It's just what? Grammar. It's the same thing we have been talking about since. If they ask you, if they say if eggs cost 25 naira each, so how much does 1 egg cost? It's just English now. Oria is English, right? It's your GS. So 1 egg is what? Keeping, if 1 egg is 25 naira, how much will n eggs cost? You can simply do multiply, but let's put it in variation form, okay? But we know that it's just simply what? So that means keeping other things constant. You know that the costs, let's put it as variation form. If you're wasting our time, but it's okay. Okay. No. KM is the unit. T is part of the value. So it cannot be 15 kmt. No. KM is, kilometer is what? The unit. Okay? This 15t is a number. 15t is a what? Is a number, okay? Yes, so it can be 15 kmt. No. Okay, now, from this question now, if he ask, I don't know why she started this. Do you eat egg much? You like egg, right? Now look at these questions. 1 egg costs what? So we can put it in variation form. That C is directly proportional to what? N. Where C is cost of what? Egg. And N is number of what? Eggs. True of us? That means C is equal to what? K. N. We were not told to find the formula, so you may not bother finding the value of K. If you want to find it, it's okay. There's no problem. But me, once my question has no business with finding the correct formula, linking formula, I'll just go straight to the point and solve my thing, because I see this as merry-go-round. So simply do what? K is equal to what? C over what? And that means C1 over what? Is equal to what? N2. We know the C1 is what from this question? 25 naira. Good. 25 what? Naira. N1 is what? 1 egg. It's not 1 egg that costs. Is this not proportion? Is this not proportion? It's proportion. But the direct, this not define variation. The variation will not define. Make another point I want to make is this. Variation is a form of proportion, but variation will not define the type of proportion we are talking about. This is a proportion, but it's a direct what? Proportion. Are we together? The one I did here before, x1, y1 is equal to x2, y2. It's also a proportion, but an inverse what? Proportion. Am I communicating? Now with this now, if we have this to 25 naira, number of eggs for 25 naira is what? 1 egg. So 1 what? Egg. It's not true. It's equal to the second cost, we don't know, right? And the number of eggs they give us at the end is what? Nx. N what? X. So let's make C2 the subject of the formula. C2 is now equal to what? 25 naira times N what? X. Over what? 1 egg. You cancel the units. Egg will do what? Cancel egg. You are left with what? 25 naira times N. Right? So the answer is what? 25 N what? 9. Or you can simply write the symbol in front. Then 25 what? N. Any of them is okay. Okay? So it's to serve. But with I just use it to show you that it's a what? It's a what? Variation. But if I see this type of question, maybe BJ, or maybe I don't need to show my work, I'll simply do multiply 25 by n and get my answer. True or false? Have you now seen how ratio built what? Proportion. And how proportion has a lot to do with what? Variation. The three work hand in what? Hand. If you don't understand ratio, you never understand what? Proportion. And you never understand what? Variation. You can just see the formula, but that's how they will treat the question. You have issues because you have issues with understanding what? Ratio. Yes. Speaker. Number 2. Will it be what? 4y. Number 2. Where's number 2? Show me. Let me see. Where is it? Blessing. 49. It says what? Number 2. Have you solved it? Solve it now. You can get the answer now. I don't know the answer. Okay, you think I know the answer of this? I don't have time for that. I have known how to solve it. So, what do you think you are giving? I have not solved them. I don't even know what they are. Bring, I will solve, and I'm going my way. If you want to go and confirm whether it's correct or not. I don't know. Okay, I don't know the answer. Seriously, I don't know the answer. But follow these steps, you get the answer. Okay, call the question. Let me even know what I just call the question. If what? If what?
1 jar of coffee.
1 jar costs what?
1 naira. What will be the cost of 4 jars of coffee?
If 1 costs 1 naira, 4 will cost what? 4 naira. Naira. Please let's go to the inverse variation quickly. Okay, let's go over to inverse variation. Let's go to inverse variation. Some call it indirect. It's not bad. Variation. Inverse variation. Now, as we discussed for direct variation, inverse variation is also talks about the relationship between two words, two items, right? Yes. But what happens here is that defining their actual relationship. As one is increasing, the other one is what? Decreasing. Are you together? So it also as a variation, it also address how the change of one item affects the change of the other what? Item. So as one is increasing, the other one is what? Decreasing, and vice versa. As the other one is increasing, the other one is what? Decreasing. And remember, I told you before now that I use academic performance as an example. Okay, I use what? Academic performance as what? An example. Now, if you have it like that, there are other factors that may affect academic performance. Am I communicating? Not reading your book, not coming to lectures. Am I communicating? If you come to lecture, it assumes that you do well, right? Good. Now, but that one is for what? Direct, provided that other factors are what? Constant. But when it comes to indirect, when it comes to indirect, you realize that the more you play too much in this school, your amount of play. You don't have time to sit down to come to lecture. You are playing, you are chatting, you are jumping up and down, gallivanting. The more you play, am I communicating? Good. Because you have put yourself in so many things, you don't have time to sit down. As the number of play, the time you spend playing is increasing. Performance is expected to be doing what? Other factors kept what? Constant. So if you use two people now, this one plays too much. He doesn't sit down to read. And her performance, and this one doesn't play. He stays in class and stay quiet in class. You realize that it's expected. Other factors between two of them are what? Constant. But if this one play, and this one come to class, but he doesn't read. They may end up doing the same thing. Hope you know. As this one is failing, this one is failing with her. Am I completing? So now that's where this constant what came from. There may be other factors that is not this even only about time you play and time you study. There may be other what factors. If you keep those factors constant, it's expected that the time you spend playing too much as it's increasing, your performance will be doing what? Decreasing. I just use what you know to give you the example. So that is what is called what? Inverse or what? Indirect variation. I will summarize so that you enter your next class. I will just, if the items we are talking about is X and Y, so we have that X is what? Unlike in direct, where you have X, this will not be 1 over what? Y. Am I communicating? This will not be what? X will not be what? 1 over what? Y. And for us to remove this sign of proportionality, we put a constant. We can use K. So that means X is now equal to what? K dot 1 over what? Y. Which is simply what? K over what? Y. So X is equal to what? K over Y. So you can find your K to be what? XY. And because K is constant at any instance, that means K1 is equal to K2, which is K3. In that case, if K1 is K2, is what? K3 till Kn. That implies that X1 for this first K, X1, Y1 is equal to what? X2 what? Y2. This is Boyle's law, remember? Yes. Boyle's law, right? Pressure and what? Volume. Now I think we'll stop here. In our next class, we will solve some questions on this before we move to what? Joint variation. Do you have any question? Huh? You say what? No, do your lecture after lecture. I told you that there's no time to waste. After lecture, I'll come back. unless there's a lecturer in your class. All right, thank you very much. God bless you.